Problem 216. The trick to solving this one is to turn the 1 over 4 into a half squared, and the 1 over 16 into a half to the 4th power. So let me rewrite this. We have 1 over 2 to the negative 3rd power times 1 over 2 squared to the negative 2nd power times 1 over 2 to the 4th power times negative 1. Then what happens is we get 1 over 2 to the negative 3rd power times 1 over 2. We multiply these two numbers to get negative 4, and 1 over 2 to the negative 4. And remember that when the bases are equal, you just have to add up the exponents. You add up the negative 3, the negative 4, and the negative 4, and you get 1/2 negative 11th power. And that is going to be answer B. Number 217. Let's see. Number 217 says, in a certain game, a large container, I don't know why I said huge. In a certain game, a large container is filled with red, yellow, green, and blue beads. So there's yellow, red, green, and blue, and they are worth 7, 5, 3, and 2 points each. A number of beads are then removed from the container. If the product of the point values of the removed beads is 147,000, how many red beads were removed? You might look at this problem and say, how do I even get started? What the heck? How am I supposed to know? Well, you may have noticed the 7, the 5, the 3, and the 2 are all prime numbers. That should give you a hint about what you have to do here. You need to take this huge number that they gave you and turn it into its smallest prime factors. In fact, you don't even need to do that. I mean, you could just start doing that and then count up the 7s. You just need to find out how many 7s are factors of 147,000. So let's start off with 1,000 times 147 to get that number. 7 never doesn't go into 1,000, so we can ignore that. 7 goes into 147 21 times. Then that's 3 times 7. 2 7s. 2 7s. D is 2. 218 says if 2 over 1 plus 2 over y equals 1, then y equals our answer. Well, this section here is going to become y plus 2. We know that whole thing is over 2, and that equals 1. Multiply, and we get 2y over y plus 2 equals 1. Cross multiply, and we get 2y equals y plus 2. Then we subtract y, and we get y equals 2. That is D. On to number 219, which says if A, B, and C are consecutive positive integers, and A is smaller than B and it's smaller than C, which of the following must be true? They give us three statements. Statement 1 says C minus A equals 2. Is that going to be true? Yes, because these are consecutive numbers and they're positive. Consecutive positive. So if C was 5, B was 4, and A was 3, 5 minus 3 would be 2. No matter what numbers you plug in, this is always going to be true. Statement number 2 says A, B, C is even integer. Well, we know it definitely will be an integer. 3 integers multiplied together will always get you an integer. Will it be even, though? Yes, because when these are 3 consecutive positive numbers, one of these will always be even. Either the A and the C will be even, or the B will be even. Either way, A times B times C is going to be an even number, and it will be an integer. So 2 will always be true. Now statement 3 says A plus B plus C over 3 is an integer. Let's think about this one for a while. A plus B plus C. So you add these three numbers together over 3. So it's 3 divisible by that number. Yes, I think that's always going to be the case. For example, you had 1 plus 2 plus 3, that's going to be 6, and that's definitely divisible by 3. If you had 5 plus 6 plus 7, that would be 18, and yes, that's divisible by 3. No matter what you pick, it's always going to be divisible by 3. When you have a certain number of consecutive positive integers, it will always be divisible by that number. So 3 is also true. And that means our answer is going to be E, which states 1, 2, and 3 are all true. 220. Says a part-time employee whose hourly wage was increased by 25% decided to reduce the number of hours worked per week so that the employee's total weekly income would remain unchanged. By what percent should the number of hours worked be reduced? Hardest part in this question is figuring out how to turn that English into an algebraic equation. How do we get started? Well, we know that, well, let's call the wage W, all right? So there's a wage somewhere in here, and there's a number of hours worked. We're going to call that hours. Hours worked per week times the wage is going to be his total wage, right? And we know that he is manipulating his new wage so that it is equal to his old amount. So what happens now? Let's see. What can we do? Oh, yes. So we know that the wage was increased by 25%. So that's the same as saying 1.25 W. And this 1.25 means the original W, which is 1, plus an additional 25%, plus an additional 0.25. So that's 1.25 W times, but instead of multiplying it by H, we're going to be multiplying by H minus some mysterious integer. That is, so we're going to be subtracting by some integer that represents the number of hours we're taking away, so that the overall amount of money he makes is equal to the amount of money he made before he got this salary boost. Whew, all right. Where do we begin? You know what? I'm going to get rid of this question mark and substitute with x. We're going to be solving for x. WH equals 1.25 W. Well, you know what? Let's actually cancel out the W's. So what we get is H equals 1.25 H minus 1.25 X. We move that over. We get, what do we get? We get negative 0.25 H equals negative 1.25 X. Obviously, we don't need the negatives. Since we're solving for x, we can say that x equals 0.25 h over 1.25, and that's the same as saying 1 over 5 h. So 1/5 of the hours that he originally worked. The answer choices are on percentages. What percent is equal to a fifth? And that's going to be B, 20%. 221. Of the 200 students in College T, overlapping sets question. So College T. Okay. These are the totals. And let's look at the sets. Of the 200 college or students in College T, they are majoring in one or more of the sciences. 130 of them are majoring in chemistry. So we have chemistry students and non-chemistry students. And there's also biology students and non-biology students. 130 are majoring in chemistry. I mean, 70 are not. 150 are majoring in biology. That means 50 of them are not. If at least 30 of the students are not majoring in either chemistry or biology, so at least 30, then the number of students majoring in both chemistry and biology could be any number from, and they give us a range. Okay, so let's deal with the least amount possible and see what happens. So let's imagine that this was 30. What would happen if this was 30? Well, 50 minus 30 is going to be 20. And 70 minus 30 is going to be 40. And 30 minus 20 is going to be 110. 150 minus 40 is going to be 110. So the answer is going to be either D or E. Now we have to find out what the upper limit is. They tell us D is 110 to 130, and E is 110 to 150. Let's think about this for a while. Can this ever be 150? If there are only 130 students taking chemistry in the entire school, how can 150 people be taking chemistry and bio at the same time? So that's why E is not the right answer. We always go by the smallest number to set our limits, and that means D is going to be our correct answer. The range is going to be from 110 to 130. 222. We are getting close to the end of this section. Wow. 222 says if 5 minus 6 over x equals x, x has how many possible different values? How many possible values? Is this a trick question? They tell us none, B is 1, C is 2, D is an infinite number greater than 2, and E is an infinite number. I guess if you were strapped for time, you might guess D or E, but this is actually pretty straightforward. 5 is going to be 5x over x. And then we just get 5x minus x over x equals x. Cross multiply, that becomes x squared. And then move everything over. You get 0 equals x squared minus 5x plus 6. Use the FOIL method. And we get x minus 3. 3 goes into 6. 2 times x minus 2. You add those together, you get negative 5. That looks right. Set them equal to 0, and you get x equals 3 or 2. So there are two answers, and that is C. Okay, that's all the time I have. So watch me in the next video.